Hi, welcome everyone. Hello, welcome, lovely greetings to all dear students. This is Nabin Karki as usual with some discussions in physics. And this class is dedicated for JEE aspirant. आज हम बात करने जा रहे हैं with the topic of units and measurement. अब ऐसा हो सकता है, आपको ऐसा लग सकता है कि enough is enough. We've talked much about units and measurement. Then see, at this stage, I will not bore you by simply talking about dimension, principle of homogeneity, and so on, so on. You know, for the next 1 hour, I have very thoughtfully picked a topic from units and measurement. और ये जो topic है, आम students को थोड़ा सा problematic होता है. अच्छा, एक तरफ तो क्या है कि this is problematic, but on the other hand, that's very important from examination point of view, and both mains as well as advanced. And the topic, the figure has been very clearly, illustrated. आज हम बात करने जा रहे हैं about the Vernier Caliper and micrometer screw gauge. If you are a medical aspirant, the first half of the discussion, जैसे for mains and advanced, हम Vernier Caliper का जो discussion है उसको बहुत आगे तक बढ़ाएंगे. But if you are a NEET aspirant, up to the calculation part or least count part, that's going to be very much relevant to you. Okay, now another thing is that during the discussion, if you have any sort of doubt, then you can WhatsApp in this number 9311883484. So that is the number, and in this number you may WhatsApp your query, but do remember the query should be exclusively based on the present topic. Okay, not beyond that. So कृपया kinematics का doubt मत पूछे. Whatever is being discussed right now, you got to focus only up to that part. And if any question is raised, feel free to respond it via WhatsApp. But yes, when you send your query or when you send your answer, please do write your name as well as your city's name, ताकि हमें पता चले कि हमारे viewers कौन से शहर से हमारे साथ connected हैं. Although via internet and satellite, it's all a global village now, so the location much does not matter. But still, अगर आ जाता है, we kind of get very much excited. All right, so let's start. Let's start with, first I'll talk about the Vernier Caliper, and after that I'll be talking about the micrometer screw gauge. First of all, okay, so these are the agenda of today's discussion. The Vernier Caliper, the screw gauge. I have very properly used maximum amount of figure. कोई कंजूसी नहीं की है मैंने. I've used it very, very lavishly so that you may train your eyes, right? The Vernier Caliper, the screw gauge. So let's start with Vernier Caliper. And please don't worry. We are going to go in a very, very greater detail, but we are going to start right from the basic, completely from elementary. And I know this is the topic where students face a little bit of trouble. So every small bits and pieces are going to get covered. And please don't look at this. This is simply a heading, a stylish heading. Now, that's a topic there, the stylish one. Let's talk about this. आइए सबसे पहले बात करते हैं. Let's do the anatomy of the Vernier Caliper. Let's try to understand what is a Vernier Caliper. A Vernier Caliper consists of two scales. One is called as the main scale, okay, and the other is called as the Vernier scale. All right, now please just see here. This is the main scale, the bigger one, and the yellow one आप देख सकते हैं, this is another scale which is the Vernier scale. So even there are calibrations in the main scale and there are calibrations in the Vernier scale. All right? And the main scale is fixed. Now this guy is properly fixed. Now that does not move, the main scale. But the Vernier scale, that is slidable. So you can slide the Vernier scale. And as you slide the Vernier scale back and forth, you know, the space between these two, and they are called as the jaw, like the jaw. This is what we call as the jaw, right? So even the Vernier caliper has jaws. Now, the white one is the main jaw, and this is the Vernier jaw. And please don't get confused with this one. You know, it's something like, जब आप इस Vernier scale को slide करेंगे backward and forward, correspondingly, this would also come backward and forward. So this is simply the connection. ये पीछे से Vernier scale के साथ connected है. Nothing more than that. So I think you have understood the figure. All right. Now, just a very, very important point. This is the main scale. This is the Vernier scale. And the entire arrangement is called as the Vernier caliper. Let me repeat it again. This is the main scale. This is the Vernier scale. And the entire arrangement is called as the Vernier caliper. So Vernier caliper comprises of main and Vernier scale. You get that point? Okay. Now here, this is a typical situation wherein we were measuring the diameter of this disc. जब हम इस disc का diameter measure कर रहे थे, then you know the Vernier scale is slightly taken back, and we fit the two jaws, you know, so that the disc fits tightly. That's very, very much important. Like you can take it backward, forward, right? But reading तभी लिया जा सकता है when this given object is tightly fitted between the main scale and the Vernier scale. Now there is a very, very interesting thing. And that interesting thing is, in fact, it's not only interesting, but it is the you know, the central design of Vernier caliper, the core design of Vernier caliper. And what's that? Let's see. In fact, the let me write it completely. Least count, okay? Least count of Vernier scale is less than the least count of main scale. All right. Now this, as I said, is the characteristic feature of Vernier caliper. As I said, this is the core design of Vernier caliper. The least count of Vernier scale, this one, is less than the least count of main scale. So typically, let's say for example, the main scale least count can be a millimeter, 1 millimeter. The least count of the Vernier scale will be something like 0.9 millimeter, 0.8 millimeter. But ऐसा भी नहीं है कि the moment you say it's less, then you take it very, very less, like the least count of the main scale is a millimeter and the least count of Vernier scale is 4 millimeter. Now, that's not allowed. In fact, the least count of Vernier scale is slightly less than the least count of main scale. So we got to use this word slightly. And there is a reason behind that. There's a specific reason behind that. Okay, now this has been done. Okay, this is the basic understanding what we have done about that. But so far, we haven't talked about the least count of Vernier caliper. the least count of main scale and the vernier scale. It's basically a simple scale, like a ruler, whose least count you know. But now we're going to talk about the least count of vernier caliper. So that's the main idea. Let's see. Okay. Now just try to understand here. Now see guys, this is the main jaw and this is the vernier jaw. And when you want to measure the least count of caliper, you start pushing the vernier scale. You push it, and finally this and this would be touching. यानी दो jaws एक साथ जुड़ेंगे. So you got to keep on pushing that. Something like a slidable one, very simple arrangement. And let's see what would happen. There's a very interesting thing, see. When the main scale and the vernier scale are touching, now notice at the figure, the 0 of the main and the 0 of the vernier, they are coinciding, right? ये कब की situation है? This is the situation जब vernier का jaw और main का jaw एक साथ, when they are touching, this is happening here. 0 of vernier and 0 of main, they are coinciding. They are concurrent, right? But then, there's a very interesting thing. Look, if you look at the figure, it's something like, let me give you an example, and we can go back to this. I don't want to take a slightest of, chance. I just want you to understand every little bit of thing. I'll give you an example. Imagine there's a circular track. And in this circular track, there's car A and there's car B. And they are racing, okay? And let us say that the speed of A is, of course, greater than speed of B. That has been given. Now, I'm not going to ask you the question, which car will win the race? That's very obvious, right? Car A would be the winner. But अगर आप देखेंगे थोड़ी देर बाद, after the race begins, कुछ ऐसा आपको दिखेगा, like A would have, A would have reached here and B would have reached here. A is moving in this direction, B is moving in this direction. You get that? Of course, because A is faster than B. Now the gap between them keeps on increasing. And after a certain time, you would again see that somewhere, I don't know where on the track, but A and B again would be together. That would happen. A and B again would be together. And can you just think what has happened then at this instant? A has covered one more lap as compared to B. A has covered one more revolution as compared to B. मान लेते B ने 3.5 चक्कर लगाया है, तो उसी समय A ने 4.5 चक्कर लगाया होगा. Because that's the reason how we can justify that A and B are together. Get that point? Now just try to understand, because I know that the least count of the vernier scale is slightly less than the main scale. आप देखिए 0-0 matching, the race begins. There's the gun, boom, fired, the race begins. आप देखिए the first of the main and the first of the vernier, the first of the main is slightly ahead of first of the vernier. Let's take an example, maybe 1 millimeter and 0.9 millimeter. If they are the least count, the difference is going to be 0.1 millimeter. But then with every scale that you find, the difference keeps on increasing. With every scale that you get, आप देखिए हर एक marking पे चलते जाओगे, difference keeps on increasing, and eventually you would find आप इस पे ध्यान देना, just concentrate on this. Again you would say, hey, the marking of vernier is again matching with the marking of mean. You get my point? The marking of vernier is again matching with the marking of vernier. और उस समय क्या हुआ है? If that is 10th division in vernier, for example, हमेशा 10th होगा, ज़रूरी नहीं है. If that is 10th division in vernier, that will be 9 division in main. Now, let's take an example. मान लेते least count of main is 1 millimeter and least count of vernier is 0.9 millimeter. Okay, for example, तो आप देखिए 10 division of 9 division of mean will be equals to 10 division of vernier. You get that? और इसी कारण से we keep the least count of mean slightly greater than that of vernier. Actually, the entire, thought behind Vernier Caliper lies on this fact that the main scale of, or the least count of main scale is slightly greater than that of vernier. So I hope you understood that when the scale again match, the vernier would have covered one more marking as compared to that of main. All right? Okay, let's see. There's an example. There's a question. What is the exact difference between vernier or main scale? If I could have your name and city, that would be really, really great. Okay, name Ashi. Okay, there's no difference. The main scale, that's also a ruler, a geometry ruler. A vernier scale, that's also a geometry ruler. There's only a difference, like main scale has a least count. I believe you know least count, right? 1 millimeter. And vernier will have a least count, 0.9 millimeter. So that's only the difference. Nothing more than that. Apart from that, constructionally they are different. Like main is fixed, vernier can slide. That's only the difference. Rest, no other differences are there. Hope so that clears it out. Okay, so this is what we have found. अब हम बात करेंगे how can we calculate the least count. Okay, so how can we calculate it? Let's see. Now we got a very, very interesting fact, and let's try to see. Oh, that had to be deleted. Okay, now let's see. Let's try to understand. Now after we have understood this particular fact, let's see here. NVSD, that means n number of vernier scale division. Like in our figure you could see 10 vernier scale division is equals to n minus 1 main scale division. Okay, so here this is the fact. Straightforward, because you could see 10, why is it? Because there is a match. So 10 vernier scale division will match with 9 main scale division. It's a fact here. Now this is going to be very important for us. Now we define the next thing. Please see very, very carefully. The least count of caliper or the vernier caliper, whatever you say. Please be careful. I am talking about the least count of the entire gadget. मैं अकेला मेन स्केल का लीस्ट काउंट नहीं बात कर रहा हूं, मैं अकेला वर्नियर स्केल का लीस्ट काउंट इसकी बात नहीं कर रहा हूं. I'm completely talking about the least count of the entire arrangement. By definition, that least count is 1 MSD minus 1 VSD. Now this is a very, very important formula. You need to keep it in your mind, all right? The least count of a vernier caliper is defined as, let me keep it in a nice box so that you can always find it an important thing. The least count of a vernier caliper is 1 main scale division minus 1 vernier scale division. Okay, now let's try to understand. Let's try to calculate the value. So if I want to calculate that value, see here, now let's see, this is equals to least count equals to 1 MST minus. Now let's try to see it from here. The previous one, n VST equals to n minus 1 MST. So 1 VST is going to be n minus 1 divided by n multiplied by MST. That's what you get. So this MST is not Mahendra Singh Dhoni. It's main scale division. Okay, all those cricket enthusiasts, perhaps you've started celebrating. So 1 VST, from here we put the value, and you just go for a little bit of calculation. Least count equals to 1 MST divided by n. So this is the least count of the Vernier caliper. What is n? N is that division of vernier. N is that division of vernier which is matching with the main. Like, say for instance, it could be 10 vernier scale is matching with 9 main scale. So the value of n is going to be 10. So, we got to go step by step. So first job we have done, how to calculate, how to compute the value of least count. So why not we see with the help of numerical, okay? Okay, let's see. The Vernier scale of a calipers is divided into 30 divisions which coincide with 29 main scale division. So if you see here, this is the value of n, because that was how we had, understood about n, that n Vernier scale division is equals to n minus 1 main scale division. Now each main scale division is 0.3 millimeter. So that means I got to calculate the least count. So that is 1 MST divided by n. Now if I have any of the viewers as NEET aspirant, this is one of the very favorite question in NEET. अक्सर NEET में least count तक ही limited रहते हैं. When it comes to mains and advanced, they go beyond and beyond. Now let's say one main scale division that is equals to 0.3 millimeter. The value of n, that's equals to 30. So quite obviously this value is going to be 0.01 millimeter. Now look at the major advantage. अगर हम advantage की बात करें, अकेला main scale, suppose you think to use the main scale as a simple ruler, as a simple scale. The least count of the main scale would be would be 0.3 millimeter. But by the use of the combination of main and vernier, आप देखें, the value of least count has substantially reduced. Least count की value काफी ज़्यादा कम हुई है. और least count कम होना is always an advantage. Okay? So दो चीज अगर कम हो जाती है, it's always a good news. One, वजन, weight, and other is the least count. That's always an advantage. And this is achieved by the combination of this. अब बात करते हैं how to take the reading of a Vernier caliper. So in order to take the reading, it's something like this, देखो. Now I'm not making the elaborate picture. I'm not making that. बस एक simple सी बात है, जिस भी object, like in the first figure I had shown that if you are, let me show it, if any viewers are new, here. Right now, we are wanting to measure the diameter of this disc. And this time, there is a certain setting of the vernier and the main scale. So I have not drawn those elaborate figure. I have simply shown this scale. I think that is what really matters for us. So here's the case. आप देखिए. While we were doing the measurement, this is the status of the main scale and the vernier scale. अब reading कैसे ली जाती है? Now you got to see two things before you take reading. First of all, see, where is the zero of the vernier? The zero of the vernier is between 11 centimeter and 12 centimeter. How did I know this as 11 centimeter? Because the fact has been given there, the least count of the main scale, right? So the zero of the vernier, let me go very, very slowly. The zero of the vernier is between 11 and 12. So first part you have done. And what should you observe? First of all, observe where is the zero of the vernier, between which main and which main. After that, you need to closely observe, and here I have simplified the job for you. I have given a green, rectangular bracket I have given just to catch your attention. But this sort of thing will not be given in your examination. You got to see the figure and you got to, comment on that. Abhi aap dekhein, this is the division of the vernier which is matching with the main. So this is always an event which will occur. ऐसा नहीं होगा कि this will not occur. तो दो चीज आपने देखनी है. Number one, where is the zero of vernier? Number two, which division of vernier is matching with the main? Okay, so that is the two things that you need to observe. So now the reading is going to be very, very simple. Say 11 centimeter. Why 11 centimeter? Because 0 is after 11th. This one. 0 is after this, right? 0 of vernier is after 11 centimeter of the mean. Plus, all you need to say is that, let's count. This is 1, 2, 3, 4, 5, 6, 7. Did you see that 7th vernier scale is matching with the mean? Let me repeat it again. 7th vernier scale is matching with the mean. So plus 7 multiplied by least count. And we are done. And we are done. So whatever is the least count. Now see, the question will be in two steps. First step, they would ask you how to calculate the least count. And second, how to go for the reading. So the first step, you would have calculated least count. And then you can calculate the reading. So quite simple. See, I did it very, very slowly so that you may catch my pace. I did not accelerate. बस आपने ये देखना है, zero of vernier किसके बाद है? So that's after 11 centimeter plus vernier की कौन सी division main के साथ match कर रही है, ये आपको देखना है. Right here it was the 7th division which was matching. That's all. That's how we do. Okay, so there's no point to worry about. That's quite simple. Now we'll talk about the zero error. All right. Now let's see what's the meaning of zero error, and after that we'll see. First of all, if I talk about zero error, just take an example. मान लेते आप अपना वजन लेने के लिए you stand on top of a weighing machine. आप काफी खतरे मोल रहे हैं because अपना वजन लेना, that's always a matter of threat. हो सकता है ज्यादा आ जाए, हो सकता है कम आ जाए, दोनों ही जो result है दुखदाई है. So you took that risk that you are standing on the weighing machine. Now imagine before you climb on the weighing machine, पहले से ही there was a reading of 2 kg. Of course, that's a bad news for you, or that's a किसी ने आपके खिलाफ साजिश की है कि पहले ही the weighing machine is showing 2 kg, right? So that 2 kg is called as the zero error. That means the reading of the gadget without any input, that is called as the zero error. So there are two types of zero error in case of vernier caliper. But उससे पहले vernier caliper के respect में, how do you understand zero error? Simple सी बात है. When the jaws are touching, if the zeros do not coincide, that is called as a vernier caliper having zero error. Let me repeat it again. While you select the vernier caliper, when the jaws of vernier scale and the main scale are touching, ideally, क्या होना चाहिए? Ideally, it should have happened that the zero of main and zero of vernier should coincide. But if that does not happen, that is called as the zero error. Now, in case of Vernier caliper, we have two types of zero error. The first one is called as the positive zero error. Now, this is a typical diagram of positive zero error. So, what had you done? You know, there's no any instrument whose length you have to measure. So, you slit the Vernier scale, and now the Vernier caliper cannot go beyond it. Okay, the jaws are touching. So, the Vernier caliper cannot go beyond it. But ध्यान से देखिए, इस time होना क्या चाहिए था? The zero of main must coincide with zero of Vernier, right? But the zero of Vernier could not reach, यहाँ तक नहीं पहुंच पाया, you could see. The zero of Vernier could reach only up to this. So if the zero of Vernier cannot reach zero of main, और उससे पहले ही जाके रुक जाता है, उसके beyond तो jaws टकराएंगे, right? The jaws will collide, उधर जा ही नहीं सकते. So that error would be called as the positive zero error. So I hope so you have understood what's the meaning of positive zero error, right? Now we would like to find what is the value of the positive zero error. The value of the positive zero error is this. That's very simple. इस समय, again concentrate, which division of Vernier is matching with the main. So that's 1, 2, 3, 4, 5, the fifth division. So that's very simple, plus y, because that's a positive zero error, multiplied by 5 into least count, and we are done. So that is the zero error. काफी हद तक reading के साथ मिलता जुलता है, because in case of reading we also add one more thing. Where is the zero of Vernier? So very much similar to that. So that's a positive zero error. Now let's talk about the negative zero error. Now in case of negative zero error, you know, while you slid the Vernier scale, and when the jaws of Vernier and main are touching, you observed that the zero of the Vernier has gone beyond the zero of the main. Right? When the jaws are touching, the zero of the Vernier has gone beyond the zero of the main. Such error is called as the negative zero error. और अगर हम negative zero error की value देखें, so that will be minus. But ये चीज ध्यान देना, जब भी आप negative zero error ढूंढते, the calculation should start from here. You can just imagine, because उधर के मुकाबले कितने आगे, you know, as compared to this, how much has it proceeded? So that's about the negative zero error. So whenever you calculate the negative zero error, you should start your computation from here. All right? This will be more clear when I'll do about the negative zero error of a screw gauge. All right. So it's something like this. Let me give you a simple example. मान लेते, right? This is the weighing machine. Again, a very dangerous machine. And let's say the scale is something like this. It's a circular one. Suppose this is, right, 0, karte. Let's say this is 120, if that comes. Now, see, actually, no zero error means when the pointer is there, it should be 0. Now, a positive zero error means when no thing is kept there, maybe it would show 1 or maybe it would show 2. That's a positive error. A negative error would be when nothing is kept, it would show 120. It would show 110 because it goes on the other side of the scale. But see, when it shows 120, it does not mean that the error is minus 120. You could say the error is only of one scale. So the idea is exactly the same. So, or if you really don't want to fall into this trouble, बस एक simple rule बनाए, when you have to calculate negative zero error, the counting has to begin from this side. Now let's say 1, 2, 3, 4, 5. This is a coincidence in this figure that this matching is happening with 5. So if somebody starts, from this side, 1, 2, 3, 4, 5, that would have been the same answer. So right here, the zero error would be minus of 5 multiplied by least count. That's how it goes. So all because the fifth Vernier scale as counted from this side is matching. All right, so that was about the zero error. अब बात करते हैं zero correction की. Let's talk about this zero correction. Now zero correction by definition is always equals to negative of zero error. So it's a very simple thing. Like say the weighing machine shows a reading of 2 kg without any object. So the error is plus 2 kg. The correction will be minus 2 kg. The error is plus, the correction is minus. So that's very simple. Okay, that's no any problem. But then the true value, all right? So the first one is the true value. That is equals to the measured value, all right? The first one is this. And plus of zero correction. Please remember that zero correction is always added. Zero correction is never subtracted. Never. Because the sign would be there. Like आप देखिए, if the error was positive, the correction would have been negative. So the sign will automatically compensate. The sign will automatically balance. So you need not worry about that. आपको चिंता करने की जरूरत नहीं है. और यहाँ पर आके एक गलती हो सकती है. Like many times, students fail to understand. It's just a formal way of putting it. Otherwise, common sense से आपको पता है. If the error was plus 2 kg, you would do minus 2 kg. If the error was minus 2 kg, you would do plus 2 kg. So in common sense way, you can easily understand. Otherwise, this is just how it goes. All right. So, we've got a numerical. And let's see. Quite a big one. Now, what does this say? A Vernier caliper has 50 division in its Vernier scale. Okay, we got to go step by step. So here, let me just solve it. Where? Okay, I need to go. All right, so there is the number of Vernier scale division that is equals to 50. Okay, let's go step by step. Let us go step by step. All right. The smallest division on the main scale is 1 millimeter. So that means, I think I can do it here. Okay. All right, let's do it here. See, the number of VST, that is equals to 50. Okay, that's the first one. If I write it here, I need not go up and down. Okay. Or I can also do one thing. Boom. That is better. Now we can do it in a single view. You can take this snapshot if you wish. Chaliye, let's see. A Vernier caliper has 50 division on its Vernier scale. So I get it here. The number of Vernier scale division, that's equals to 50. The smallest division on the main scale, that's 1 millimeter. So the Mahendra Singh Dhoni, that is 1 millimeter. All right? When the jaws are touching, let's read. When the jaws are touching, zero of Vernier is between 0 and first division of main scale. So up to this point, what do you infer? The error is positive or negative? Obviously, the error is positive. And let's see how much is the error. The 8th division of the Vernier scale coincides with one of the main scales. So that's quite simple. Plus 8 multiplied by least count. This question is a complete package. Balanced diet, complete nutrition, protein, carbohydrate, everything you'll find it here. the least count, the error, the values, and everything. Now let's see. While taking a measurement, 0 of vernier, now this is time of the measurement. While taking a measurement, 0 of vernier is between 15th and 16th division of mean. So let's write it here, the reading. All right. So the reading is going to be 15 main scale division plus 39th, right, division of the vernier coincides with that, multiplied by least count, and plus of 0 correction. That's all. That is all. Right? Now, what is the correct value of the measurement? Let's see. All I need to do is that I got to calculate the value of least count. So here I can do it something like this. I think we can do it in one step. Okay. So इस data की मदद से we can calculate the least count, that is 1 divided by 50, and that is 0.02 millimeter. So that is the least count of the gadget. Okay, 0.02 millimeter. बस अब reading देखते हैं. 15 main scale division, so that's 15 millimeter plus 39 into 0.02, so that's going to be 0.78 millimeter, and 0 correction is minus of 0 error, so that's minus 0.16 millimeter, and we are done. Whatever was the error, we put a negative sign, so that's going to be the 0 correction. So इस तरह से we find the complete answer of any given question in Vernier Caliper. So this is the ultimate level where everything has been included. The error, the least count, the correction, the measurement, the true value, everything. All right, so this is how we say. Let's not say reading. Let's call this as the true value, because we've already made a compensation of 0 correction. So if you have made a 0 correction, you got to say that as the true value. So guys, hope so now at least you would come up as a very confident person as far as Vernier Caliper is concerned. Now, we've dedicated quite lots of time for Vernier Caliper. This is certainly going to help us for screw gauge. Micrometer screw gauge or simply screw gauge, that's what we call. आप देख सकते हैं, there is a circular scale right here, okay, and here is the main scale, and this is the point which we can rotate, and as I rotate this handle, like say if I rotate it in this direction, notice the direction, you got to use the right hand screw method, so left-handers please be careful. As I rotate in this way, right, this one is going to go in this direction. It's something like you open a bottle cap or you close a bottle cap. The idea is that. आप देखिए जैसे जैसे हम इसको ऐसे घुमाएंगे, this particular thing ये इस तरफ जाने लगेगा. And if I rotate it opposite, then this will come and open in this way. और एक चीज, अगर मैं इसको close कर रहा हूं, this scale will also go together with this. Okay, so this one is going to go in this direction. As I close this, यानी main scale would be hidden. Main scale ढक जाएगा. जितना ज़्यादा rotate करोगे, this is going to go there, और इसी के साथ ये भी आगे जाएगा. इसका मतलब this and this, they are connected. So as this goes in this direction, the main scale would be covered. And the opposite of that, if you rotate in this way, more and more main scale would be exposed. All right? So this is the basic anatomy of the device. And the one that you want to measure, like let's say you wanted to measure the diameter of this sphere, so that will be kept there. Okay? So in that way. And this would be tightly fitted as what we did in case of Vernier Caliper. All right, now let's talk about the least count of the screw gauge. Now the least count of screw gauge is very simple. That least count is equals to pitch divided by the number of circular scale division, CST. That's the circular scale division. Now, MST was Mahendra Singh Dhoni. CST does not have any full form, right? So that is the circular scale division. Now, that pitch is also 1 MSD, the main scale division. And in fact, pitch is also when the circular scale completes one rotation on either side, this advances or closes by one main scale. I think that's clear. Like if you make it one complete rotation, suppose you are opening it up, तो अगर पहले suppose if 50th division of the main was visible, now after one revolution 51st division would be visible. So something like that, right? That's how it goes. Okay, so this part has been done. Now let's see how to go with the reading. Now the reading, देखो, there's no any big thing right here. If you have really understood the Vernier Caliper, screw gauge is quite simple. Now let's see here, the reading, the least count of the gadget has been given as 0.01. So the reading is quite simple. Look, the reading is going to be 6 main scale division. Why 6? Because the 6th division is visible. And there you saw that which vernier was coinciding. Here we see which circular scale is coinciding. And have a look, this is the circular scale which is coinciding. And that's the 41st division. So 41st multiplied by least count. That's all. Now, since in this question, the main scale, okay, that has been, I'll assume it as 1 millimeter, all right? It's almost evident, although that should have, that if that was given, that would have been a wonderful thing, plus 41 into least count, so that's 0.41 millimeter. So the reading of this case is 6.41 millimeter. Quite simple and quite easy, right? It's quite simple. This is how we do. All right, now in the similar way, there we had positive 0 error, negative 0 error. Even in case of screw gauge, we have positive and negative 0 error. So this is the situation of positive 0 error. That means, जब हमने circular scale को पूरी तरह से tight किया है, once we have tightened the circular scale completely, that means what happened was that this has, touched this. Now that cannot go beyond it. So you have completely tightened it. Once you've completely tightened it, this goes and touches with that, right? And that can't go beyond it. So in that situation, now you could see, this is a case of positive 0 error. A positive 0 error where, very similar. Now try to have a comparative view. Look at the analogy. वहाँ पर Vernier scale 0 main तक नहीं पहुँच पाया था. That means the 0 of main, the 0 of Vernier could not reach the 0 of main, right? And the idea is similar. Now see, actually the ideal situation was this 0 should be just hidden, but as we tightened it, we could not go beyond it. Now we are stopped here. We can't go for further tightening. And that's a case of positive 0 error. And let's see, how would we calculate the positive 0 error? So that's very simple, plus. And again here, the 6th division is matching. So that's plus 6 into least count. And that's done. Now conversely, let's see the case of negative 0 error. Now, negative 0 error may really confuse you. You got to see that if this is 0, the the upper one would be 1, the upper one would be 2, and it goes in cycle, comes, so 90, 95, 96, 97, 98, 99, and 0. You should remember, it's a complete cycle. Like if you see, it starts from 0, then 1, and eventually 99. That's how it goes. That is how it goes. So you got to understand this thing. That's the ultimate point that you need to understand there. Like Vernier Caliper के case में भी negative zero error, मैंने आपको बताया था कि when we reach screw gauge, there will be understanding this to a very great detail. All right. So now it's a time that we understand. Ideally, what should have happened? Okay, the first thing is that why is it negative zero error? That is very important because the zero of the main is not visible. Since the zero of the main is not visible while it was completely tight, that means something like the aeroplane skids in the runway. There was a skidding. That means it went beyond. Like this was the typical situation of positive zero error where it could not reach there. But the opposite of this, that it reaches here and it goes beyond. Now the zero is not visible, all right? And now just try to understand how many excess circular division did it go? How many excess circular scale division did it go? If you see, it's only 4 because the circular excess, now don't say 96, 1, 2, 3, and 4. Ideally, this guy had to be here, matching with the main scale. Now, this is the main scale, all right? This is the reference line, the main scale. Ideally, this should have stopped here exactly. But did you realize, additionally, excess number of division, it's not 96, remember. The excess is only 4, 1, 2, 3, 4. So now, if there was any sort of confusion for negative zero error in Vernier caliper, this is going to clarify everything. And the negative zero error this time is minus of 4 multiplied by least count. That's how it goes. Additionally, it goes only 4. All right? Okay, and the correction would of course be negative of that. That's the same story. So let's see with numerical. This also seems quite long, but not to worry. Not to worry. Let's see. Let's go step by step. The distance moved by the screw of a screw gauge is 2 millimeter in 4 rotation. That means when you rotated the circular scale, all right, when the circular scale completes 4 rotation, it moves by 2 millimeter. That means the main scale opens up by 2 millimeter. So from this, I can find one thing, that one main scale division is 2 by 50 millimeter. That's all, right? One main scale division. And that comes out to be how much? 0.04. That's what it comes. That's what it comes, right? Now further, let's see, 0.04 millimeter. Okay, now apart from that, and there are 50 divisions on its cap. So the number of circular scale division is 50. So I get the least count as 0.04 divided by 50 because that's what it says. There was a slight error. Sorry for that. Let's come there. I missed the value. Let's see. The distance moved by the screw is 2 millimeter in 4 rotation. That means the main scale division is 2 millimeter divided by 4. Because main scale division, you see, for one rotation, what is the distance advanced? So that comes out to be 0.05 millimeter. That's how it comes. Right? 0.5, sorry, lots of. Okay, 0.5 millimeter. Now let's say there is a 50 divisions on its cap. So you get that the least count is 0.5 divided by 50 millimeter. So that's quite simple. You can do 0.01. Now, when nothing is put between its jaw, 20th division of circular scale coincides with the reference, and 0 of linear is hidden from the circular. So the error will be minus 30 multiplied by least count. Remember, there are 50 divisions, but the counting has to be from the back in the case of negative 0 error. And now let's try to see when the measurement part, main scale reads 2 division. So the reading will be 2 main scale division, which is 2 into 0.5 plus 20 into least count. So because 20 divisions is being matched. And finally, the true value is equals to the reading plus 0 correction, which you know 0 correction is minus of 0 error. So I hope all the discussions were clear. I will catch you up in the next one with some more interesting fun facts and matters precisely contextual to mains and advanced. As of now, allow me to sign off. See you there.